Hi, it's Mr. Benson here. I'm just making a quick video to introduce congruence and similarity. So this is a geometry, not geography topic, which shouldn't take very long. Now this is something that's quite useful, especially if you're going on with some more advanced maths later on. Also, a couple of the ideas like ratio and scale are pretty common in other subjects. For example, chemistry. Ratio is a basic skill there that becomes quite important. Ratio and scale are also really important if you are a builder or something like that. So if you want to look at drawings and convert the information on the drawings into measurements that you have to make, you need to be good at this. So ratio. Generally we're comparing quantities of the same kind, so it might be the height of something compared to the height of it on a map or a drawing. Because you're comparing two things of the same size and just saying that one of them is a certain amount bigger than the other one, we don't have any units. Now it is usually written in the form with the colon, so this is this form here, so 1 to 4. It's a common form of the ratio, or generally speaking A to B. Now we can write it in a fractional form, so 1 over 4 or A over B. Now what that's saying is that when we have our two quantities here, A and B, it's saying that A relative to B would be given by this fraction. Now there is another way of expressing it that you'll run across sometimes, which is slightly different, but this is the way you'll see it in the book. That probably doesn't make sense at the moment, but we'll do some examples. Okay, for example, I combine 1 cup of lemon juice with 4 cups of water when I'm making lemonade. Now what I'm talking about here is the ratio of lemon to water. And so I would just write that ratio as 1 to 4. Now if I was talking about the lemon compared to the water, I'm going to have 1/4 of the amount of lemon compared to the amount of water. So this is expressing it as a fraction. If I was talking about the amount of water compared to the lemon, I'm going to have 4 over 1, or 4 times as much. Now I mentioned before that there is sometimes a different way you'll get asked this sort of question. I just want to mention it, but I don't think it's actually going to come up in the textbook very often. But one thing you are occasionally asked is how much of your lemonade would be the lemon. Now what you've got to think about there is that you've got 1 cup of lemon and 4 cups of water, so you've actually got a total of 5 cups. So if you were trying to think how much of your lemonade was lemon, it would actually be 1 over 5, and how much was your water would be 4 over 5. And so you can see that we've actually got the same ratio here, so we've got 1 part of lemon to 4 parts of water, but as a fraction of the total thing that we're making, it's 1 over 5 compared to 4 over 5. Now, like I said, I don't think we'll need to think about this very often, but it is worth mentioning it as it's another example of ratios that you will come across. Scale. Pretty simple idea again. It's just comparing the size of an image compared to the original image or object. Or comparing the size of two objects. You can still use scale. Now the scale factor is basically the image length divided by the object length. Now these are sometimes expressed as ratios as well. We'll do some examples of this in a moment, but if you had something where the image length was half the object length, then it would be 1 over 2. Now you might also see this as written as a ratio, so that would be a 1 to 2 ratio. So it's basically saying that for each 2 units of length of the object, there's 1 unit of length of the image, so it's half the size. Now images can obviously get smaller or get bigger, so if the scale factor is less than 1, so in this case here 1 over 2 is 0.5, so that's less than 1, our image would be smaller. If it's larger than 1, then our image is enlarged. So Images are reduced if the scale factor is less than 1. They're enlarged if the scale factor is greater than 1. Now if we know the scale factor, we can calculate the image size based on the object size, or vice versa, and I'll show you that in a moment. Okay, calculating the scale factor. Now sorry, I should have labelled these. Let's call this one our image, and let's call this one our object. So the scale factor is just the object size over, my bad, I got that wrong. I will scribble that out. It is the image size over the object size. So it's the always comparing the new thing we're creating, if you like, over the original. So in this case, I've made my image 20 centimeters. I've made my object is 10 centimeters. So my scale factor would be 20 over 2, or 2. Now we can see here that if this was our object here and we've gone to our image here, we've obviously made it larger. So, and you can see here with a scale factor of 2, this is greater than 1, so that corresponds to enlargement. The other way of writing that as well, like I said, is you'd sometimes see that as 2 to 1 as a ratio. So it's saying that the size of our image is 2 to each one of the object. Calculating image size, so it's exactly the same thing we did before. Now in this case I've got an object which I'm saying is 20 centimeters across. I've got an image which has a scale factor of 3. Now you can see that that's bigger, and also we know from what we've said before that a scale factor of 3 corresponds to enlargement. Now if scale factor is image over our object, now I want to find the image size. So if I'm rearranging this, now this is going back to the equation stuff that we've been doing before. To get I by itself, I'd have to multiply both sides by O, and so I would equal SF times O. So it's the scale factor times the object size. So in this case it would be 3 times 20, which equals 60 centimeters. Now although the scale factor doesn't have units, your lengths do. So make sure that you're showing those quantities that should have units actually with units, or stuff isn't going to make sense. Okay, hopefully that's sufficient now that you can have a go at 5A, the exercises on Compass, as is the chapter and the answers. So speak to me or Mr. Piper if you need any help.